Hi, I'm Dr. Michael Moutoussis, and I'm going to tell you about EEG and MEG pre-processing. This is a tutorial, and it is part of the SPM course by the Department of Imaging Neuroscience at UCL. So, as an overview, we are going to look at downloading the data and starting SPM EEG, importing the data into SPM and choosing time intervals or epochs of interest. We're going to do a bit of housekeeping, such as using files to exclude bad data, label conditions, and other housekeeping items. We're going to do some basic signal processing, which will include downsampling and baseline correction. We are going to visualize and review our data, our basic data, and then we're going to re-reference the EEG to the average recording. And we're going to talk a bit about artifacts and their detection. Then we're going to introduce ourselves to averaging with a view to looking at evoked responses. And finally, we're going to convert our data to so-called images, which is 3D data sets that are suitable for statistical analysis beyond pre-processing, which is hopefully what you want to do with this pre-processing. So you probably have already used this link to download the data. If not, please do so. It's going to take about 3 minutes or so. And now, once you have saved the data in a drive which has got enough space, right-click on the zip file and click Extract All if you are using Windows, as is shown on the right. Do this in a directory which you can use for now. And note that the work that we're going to save as batch files will be specific in general to the place and the machine where you've made them. You can download more interesting and richer data than this and do a fuller pre-processing practice using this FTP link. And if you have actually not used FTP before, you can use the program that I have the URL there for, FileZilla, to do so. So start your MATLAB and navigate to the directory that you have downloaded the data and unpacked it, and specifically to the sub-15 subdirectory or folder where we're going to do our work. And this already has some files in it, but we'll get to that in a minute. So type SPM EEG on your command window, as is shown here on the bottom right, and press Enter. And this will bring up the SPM interface. You probably have SPM 12, but you probably have SPM 25 if you have downloaded SPM recently, but the same principles apply. The interface consists of a big graphics window, a progress window, and a menu window. And we are going to be mostly using the batch from this menu window, which is the bottom row, and the display, which is at the top left of the bottom panel. So click on the batch, and this will bring up the batch editor where we are going to do most of our work. And within this batch editor, which is basically making a series of steps of pre-processing into a script or a file that can be rerun, There is a menu there, and the fourth item along is SPM. So click on that, and you'll notice MEG and EEG, and click on conversion to import our data. Conversion just here means importing our data from other formats to SPM. Once you've done that, a job will appear on the module list. And most of the jobs that we're going to use are going to have some source of input, usually a file. So click on the file name, and then click on the specify button, the blue button, towards the bottom of the batch editor menu. This will bring up a navigation window in SPM, and it'll be already in the folder or directory that has the files that we're going to pre-process. So you're going to see there a file called run01 SSS, which is actually a spatially filtered file. So it's actually a rather nice source of data for us to pre-process. Click on that. And when you do that, when you click on the file, it will disappear from where you clicked it and will appear on the selected row just at the bottom of the dialog window over here. Once this is done and the file has been clicked into this window, you have to press done, which is just above it, to continue for this to register. So now the run01 SSS has been loaded, and we want to now select data out of that. And the data are going to be time intervals around particular stimulus presentations. And these data segments that we're interested in are called epochs. So we have to click on the reading mode task of the white window, and then a selection is going to appear on the gray window below it, which says current item. So click on epoch on that. And now when you've selected epoch, you have to again specify a source of data, which is mandatory and marked by this X. So when we've clicked on that, we have to specify again by clicking the specify button, the trial file that contains the specification of these data segments. So you will see that this is a MAT file. As I say, it's got extension MAT, which is a MATLAB data file. And we're going to select it again with the dialog that comes up with specify. Again, when we click it, it will appear selected, and we have to click done right here at the bottom. This is just what I've described already. Now, optionally, you can go back to your MATLAB interface and drag in this trial.def.mat file from your current folder to your command line, and then click on the workspace on this a piece of data, this variable called TRL, which will show you the structure of this data object that specifies the epochs. So this, you're not going to actually modify that during this tutorial, but if you actually work with your own data, you need to know how that is made. So the first, so each row has got an epoch. The first number is the time in milliseconds where the epoch starts. The second is the end of the epoch. And the third is the offset in milliseconds of time zero within that epoch. Okay, so 220 milliseconds in this case after the start of the epoch, there is our trial zero, there's our time zero where our stimulus was presented with within this data segment. So now we're going to do something which we're going to do again. So take note. We've selected our data, and now we're going to select the channels within the data. So click the channel selection, and in the gray panel, the current item panel, scroll down, and there you will see an item saying delete all. So many a time we're going to perform an operation on a selection of channels or a selection of items, and we'll have to remove this all default. Sometimes we're going to keep it. So click on that, click on delete all, and now click again on the channel selection, and this was going to bring the option of selecting channels by type. And this is going to be in the gray box. You click on that, and now you have to see what the types are of channel that you want. So we're going to select the EEG type, and then we're going to repeat. That's to say, we're going to click on the channel selection in the white panel, and then click again, select by channel type in the gray panel, and then select MEG planar for our first type of MEG data. And we're going to repeat this whole procedure, channel selection, select by channel type, and then select MEG mag for our second type of data. And this is what the result should look like. Now, if you make an error, feel free to try things out, because if you make an error, you can always scroll down on the gray box to a delete option and delete the thing that you didn't like. You can also try right-clicking on the various items in this box in general, and it will give you an option depending on what the item is to maybe delete or re-edit or enter new data. So don't worry about mucking about a bit and making mistakes and going back. But this is what this bit should look like once you've done it. So this concludes our first module or job, which was importing our selected data to SPM. Next, we're going to do some housekeeping, namely preparing the data by removing optionally bad channels and labeling conditions. So we're going to click on SPM, MEG, Preprocessing, and Prepare. And this will add a module or job to the module list on the left. Now, when this Prepare module has entered, we have to provide it with the information that it's going to use. But now, instead of providing a file, we're going to click on the file name on the white box, but then click on dependency below on the lower part of the menu. And this is going to bring up an option to take the output of another job that we've already specified as the input to this job. So here we're going to click on conversion and press OK. And then this is going to provide the input for this module. Now, this bit is going to be, the next bit is going to be a little bit complicated with a lot of clicking, but conceptually not challenging in any way. So what we're going to do is going to set some channel types, which are not labeled nicely in our data, to what the true nature is. So channels EEG 61 to 62 are actually electrooculogram channels. EEG 63 is ECG, and 64 is a free-floating one, which we're going to just put to other. So the finished job is going to look as it appears on the screen, but this is a step-by-step procedure. So we're going to select tasks in the white box, as you can see underneath the file name over here. We are going to have to remove this default selection of all channels. So the set channel type will appear in the gray box. We're going to click on that. Then we're going to select the channel selection in the white box, which you can see is just below the set channel type. And we're going to scroll down and delete the all option, exactly as we did in the previous slide. So if you miss the mechanics of this, you can always use the previous slide to see how it's done. Now we're going to click on the channel selection again, okay? And in the gray box, we are going to click New Custom Channel. And we're going to click this twice, okay? So we're going to have two custom channels that need a new channel type. So we are going to click on the custom channel with the X next to it that has now appeared. Click Specify and fill in EEG 061. And then we're going to click on the other custom channel that we have got. And we're going to click on Specify again, fill in EEG 062. Next, we're going to click on the new channel type in the white box. And the option for EOG is going to appear in the gray box. So we're going to select that, and things are going to look up to the point of the red arrow. So we are going to do the same procedure again for the ECG and the other, which I'll leave you to do. While you're doing that, I will tell you about an optional step here, which is specifying bad channels. Now, we're not going to use bad channels in this demo, but if we knew for certain that certain channels were bad, we could specify them. And one way to do that, probably the most practical way, is to create a mat file, say bad_ch.mat, and in that we store one MATLAB variable, and that has to be called label. And this is going to be a cell array, and it's going to have in it 2 character arrays. as it shows on the screen if I wanted to say that EEG 31 and 43 were bad channels. Then we would select new task, and we would now select set or unset bad channels. We would remove the all as described above, and this is particularly important, and it's rather interesting that they have this default to mark all channels as bad. So it's important that we do that. Then we're going to click on channel selection, then new channel 5, and then we're going to load there the bad channels that we have prepared a file for. And what that's going to do in future is not actually use that channel, but instead interpolate the others to fill this in. Okay, so what we can do now is save our work. In SPM 12, there is a rather cute floppy disk icon, which you can click for that. And I would suggest that you choose the option in the menu that appears to save as both a batch, a MAT file, and an M file, which is a script file. Okay, so the script version appears on your screen there, and I'm about to save what we've done as demo batch 1. Okay, now double check that both the M and the MAT files have been saved, and if one of them is missing, save again. Here with the script option, otherwise with the MAT option. Now, what we could do is run our batch. So our batch so far now is runnable. Now, if you do that, click the run triangle on the batch editor. It'll run our job. But in the beginning, particularly if you're using a modest computer, not much is going to show. So don't be thrown off. Wait until it has finished. And when it has finished and all has gone well, you can go to your MATLAB interface, which will have some interesting things in it. So first of all, the output file is going to appear. And here it's going to be something which is called SPM EEG run 01 SSS.mat and .dat. And then there's going to be an auto-generated script, which is shown on my screen in the middle, and which is basically a skeleton that you can actually edit if you wanted to do this particular batch again and again. For example, if you wanted to do it for many files. And you will notice here in there that there are some items that are machine specific. That's why the caution in the beginning of the talk. Finally, the command line window below on my screen will actually show a log of the processing, and this will actually include any errors. So if your batch file has got mistakes, it'll say there that it did not manage to complete. And the kind of mistakes that you usually get is because you've actually misspelled something in one of the specify boxes, that kind of thing, or there's something missing. So double check that way. All right, for our next bit, we're going to do downsampling. So that's slightly more exciting than the housekeeping that we've done so far. So again, go to the SPM menu of the same batch as we had before, MEG, preprocessing, and click on downsampling. And this will add a job. And this job, now we want us to specify its data that it's going to use. So again, we're going to fill in this through a dependency, which I have already done on this screen, through the file name item. And here I chose the previous job or module, of course. And then a slightly more interesting, we're going to need to specify the new sampling rate. And when we click the new sampling rate and we click specify, let's fill in 200, which is 200 hertz, which is twice the highest frequency that we are interested in this analysis. So in order to be able to locate a wave of a particular frequency, you need to sample at least twice the frequency of the wave, if this is a sine wave. Okay. So our next step is again a data processing step, and it is going to be a baseline correction. So we're going to start measuring our potentials that have been caused by the task, by the stimuli, by using the period just before the stimulus as a baseline. So again, we go to SPM, MEG, preprocessing, and then click on baseline correction. And we do the same thing with a dependency. We make it depend on the previous step of our batch. And now we are going to say what the baseline is, that the interval, the time interval that is going to be used as baseline. So here I have put minus 100 to 0, which is the 100 milliseconds before that 0 point where the stimulus appeared in our epoch. Okay, the 0 point of our epoch. And note that there I have specified it as a MATLAB vector with square brackets. You'll notice that there's an option for a file name prefix. Every time there's a step of the preprocessing where the data is processed, the resultant file which is stored is added a prefix. So it will have added D for downsampling and B for baseline correction to the previous file that is used as input. Okay, so here's another optional module, and you can do this or catch up with the previous steps if you're a little bit behind. You can actually delete the intermediate steps that we used to save disk space. This is certainly not that crucial. And you do that by going to MEG and clicking on Other, and then clicking Delete. Sorry, these red arrows are not so informative here. And then you can right-click in the module list to replicate the module, and we can do that 3 times. I've done that 3 times, going from the middle to the right panel of the slide, so that we have 3 delete statements. And each delete statement is going to ask us what file name to delete. And as you can see on the right, I'm going to use the dependency button. You can just about see it on the right. And I am going to select one by one the first 3 steps, the first 3 jobs that we're no longer going to need once the baseline corrected data is ready. Okay, so now we've got a batch that we can nicely use. So we click the green button, and what should happen is that the SPM progress monitoring panel will tell you about the progress of the job as it shows on my screen. Again, these things don't take very long for this demonstration, just a couple of minutes. You can start that if you want, and let it cook while you watch my next bit of the talk. So what we've done is we've done our key pre-processing, and next I'm going to talk about visualizing our data using SPM. And here we're going to go back to the SPM main menu, which on the slide is on the left. And we're going to click on the display menu. And on the display menu here, we're going to use MEG as the item. We're going to click that to display data. This is going to bring up a file selection menu. And again, you're going to click on a file to select it. Is going to then move from the right panel to the bottom line, as I have already done there. And as you can see, I have clicked on the BD SPM EEG run 01 SSS. So BD here are the initials that have been stuck on that to say that this is downsampled and baseline corrected. And once we fill that in and we press done, the panel on the right is going to appear in the main graphics. So here you can click on the info tab, and this will show you in the channel tab, which is a little bit below the info tab, a little bit to the left, the list of all the channels, all the sensors that are in our data. And this may also, this list may also give you information about trials and about conditions. But for that, you would have to click the trials rather than the channels tab. The in we are not going to deal with today, is about using an inversion transformation to locate sources of our signal. And the history, it just records what has gone on into making the file that we are displaying. So let's click on the EEG tab to see our raw data for a selected trial. And this is what it looks like in all gory detail and all the channels. And I have chosen there in the box on the right top, trial 11. And you can see it says what the trial is and what the condition is, which in this case, it was familiar. When it says not bad, it means that we have not actually specified this trial, this epoch as bad, but we could actually do that manually here by clicking on the button which is yellow. And you can see that there are various other options for increasing or decreasing the scale, magnifying, but also of showing things as they are located on the scalp rather than one channel under the other. And if you click on the scalp data, you are first going to get the panel on the left, which has got a mini time series located in the position of each channel. And if you click on the colorful item or colorful picture of a scalp on the left, then the panel on the right is going to appear. And here is the topography, the interpolated topography of our signal. And at the bottom, you will see that there is a bar with time within this epoch. So this does not show you the whole data at once. You will have to go right and left on the slider to see different data at different times in our epoch. Okay, so we've done some reviewing, we've done some basic preprocessing. Now we're going to talk about re-referencing the EEG signal, and then we're going to talk about artifact detection. So let's start a new batch file. Hopefully you have saved the previous one. But it doesn't matter as long as you've got a data file to play with. So now we're going to add a new module in the usual way in a new batch, clicking SPM, MEG, preprocessing, prepare. And the file name, we're going to use the BD SPM EEG file that we have just created and displayed. And now in the select tasks, the tasks that we're going to use for this to apply to this data, we're going to scroll down on our gray box and find new create average reference montage. And we're going to select that. I've said this already about filling in the detail. And again, I have described how you select the tasks, create average montage. And when you have actually clicked on this, a new line will appear with an output file name, which is going to be something ending in montage.mat in your white window. Okay, so now we're going to do another bit of housekeeping. And this is useful for future statistical ease of writing what we want the SPM to do is for us to specify things more easily. As you can see, we have clicked select tasks again, and in the gray window, we have actually selected sort conditions, if you can do that. So in the sort conditions now, if we click on that, the options are going to include a new condition label. So we click on that, and then we go back and forth between the specify conditions and the new condition label, specify conditions, new condition label, to have 3 of those, because we're going to order 3 conditions. So now we're going to click on the condition label that has got an X in it and click specify. And we are going to put in order famous, unfamiliar, and scrambled. And here I just display the scrambled one. But make sure that what you type here is exactly the same as the label in the condition in your data, because otherwise the job manager is going to throw up an error. It's going to not be able to find what you wrote, and you're going to be trying to debug it. Okay. So once we've done that, we've actually created the average reference file, and we have reordered our conditions nicely. We're going to add a montage module that we're going to apply this average. So SPM, MEG, preprocessing, montage in the usual way. And we're going to use dependency to fill in 2 things. The top file name, like before, is going to be from our previous job. That's to say the prepared data file. So it's going to give us the option for prepared data file. So if you do that, and here you can see it's filled in the file name. It's going to have a second thing for us to fill in, which is the montage file name. And that we are going to also fill in with dependency. So we click on the montage file name, we click dependency, and now we choose the prepare average reference montage module from the options that appear on the pop-up. Okay. Finally, we are going to change the option which is underneath the highlighted gray montage file name in my screen. So if you want to click on that, the key other channels, you're going to change that in the gray box from no to yes. And this is because we have applied the average reference montage to the EEG channels, and we do want to keep our MEG channels that we have not applied that. So again, let's back up, save as .mat and .m our batch, and run it by clicking on the now green run triangle. On my screen is gray, but once you've pressed OK for the montage file name and you've kept the other channels, it's going to go green. And now this is going to write a file that adds a big M for montage in front of our data. Well, it's going to do 2 files, a mat one and a dat one. Dat one has got all the bulk of the data, and the mat one is what we use to interface with that. Okay, so please do that. Please run this batch. And let's go to the next step. So the final leg in this particular tutorial is going to be readying the data for statistical analysis. This is our final leg. And to do that, we are going to crop the data. This is just to demonstrate. Actually, it's beyond applying average reference that my slide says. We're going to crop the data. So we get a new batch, And then we go SPM, MEG, preprocessing, crop. Here we load our new data file, the one that starts with capital M. And let's select a time window. So instead of -infinity to infinity, let's click on that, click on specify, and say -100 to 800, which is going to be 900 milliseconds around the stimulus, which is smaller than the epoch that we had. This is just for demonstration. Now we go to a more interesting bit, which is a bit of a sophisticated art. And here we're going to have only the opportunity to deal with the simplest way of doing it. And this is artifact detection. So things like eye blinks that may cause artifacts in our EEG. Go to SPM, MEG, preprocessing, and this now will have, you will see an option called artifact detection. Link it by dependency to our previous module, as we have done now a number of times, to the cropped MEG data file. Now, we are only going to use a small number of channels to tell whether there's an artifact or not. Specifically, we're going to look at the EOG channels. So we are going to click on channel selection underneath how to look for artifacts method. And first, we're going to scroll down and delete all. And then we are going to select the new channels, and we're going to select channels by type, which I have not shown in detail here. But if you click on channel selection, you will see in the gray box, select channels by type. You click on that, and then you specify EOG. There's going to be different channel types that you can choose, and you choose EOG. Then we have to use the detection algorithm. So we click on the detection algorithm, which has got a big X next to it. And we're going to use a simple threshold, which means that if there's too much of a signal in these EOG channels, we're going to drop this particular segment of data. Let's click on that and click on threshold channels in the gray box with the current item, and then click specify. This will give us a choice to fill in the threshold level, and we're going to put this 200, which stands for 200 microvolts. Okay, next, just for illustration, I'm going to show you some averaging, okay, which is what we do to display ERPs. Although you are not going to use this for your stats, you would be using a more sophisticated way of analyzing the signal. But it's very nice to see here. So, as usual, create a new module by clicking MEG averaging as it shows on the screen, and link it to the previous step using the dependency button in blue on the screen. There's going to be an averaging type that appears. And there's an argument to select robust averaging, which is good if your data has got outliers or unequal numbers of trials between conditions. But it may introduce frequency artifacts So for now, just stick with the default, the standard. And now we have created this average file by running our, if we run our batch, it's going to create an average file, which is now going to have only one average waveform per trial type, per condition. And here I have used the main green menu. I have selected the display and MEG, and I have exactly like we did before. And I show you, just for the sake of illustration, what the trial one, which is. And you'll see there what the trial one average waveform is. That's to say that's an average evoked response, and the scalp distribution at 350 milliseconds. And you have to admit that this is quite pretty of SPM to do. Okay, but why, in order to, when you do this for real, you are actually not going to use, you're not going to go very far with these averaging data. Average data. We want to ask questions like, how long does it take the brain to detect something? In our data, whether face is familiar or not. Or where in the brain this happens, or in our case, which sensors might be most sensitive to this change. I may ask, is the fusiform face area something that shows evidence for this detection of whether a face is familiar or not? And to do this kind of test, to ask these questions statistically, SPM uses three-dimensional data sets, which is like volumes. And this is an image of a volume. There's each three-dimensional data set, but here it's a bit more abstract than structural or functional MRI scans. So the three dimensions of each data set is the scalp position times the peristimulus time that we showed before. So the stuff that we've actually displayed before. And the series, or the fourth dimension of these volumes, is the trial. So each trial has got one of those images that we're going to create. So using such data sets, SPM can form contrasts, for example, of the voltage difference between familiar versus scramble trials, and do statistics to see whether the difference between these in a particular scalp position is significant. So the last thing we're going to do is just construct these images. And when we've done that, this is what it's going to look like. So on the left, you see the scalp slices, which is going to be loads of them for each step in peristimulus time. And they are organized left, right, and back, front when you see them as on the left. But also, they're going to be shown as on the right, with peristimulus time going up. And there's two columns where left, right is the x-axis on the left column, and front, back is the on the right column is the hair crosshair on the right column. So finally, we're going to make a new batch, SPM MEG images. And now we're going to select convert to images. Okay, we're going to select a data file for example, we can select our file starting with capital M for montage. And then we're going to use the mode, which we have to fill in the mode, which is just under the file name. And I suggest for this demonstration that we use scalp times time, okay, which is going to appear on the gray box as you can see. Then we have to click on channel selection, select channels by type, and here select EEG. This is what I have just described. Select EEG. And when we run the batch, we're going to see again the monitor. And now the output is going to be a whole new folder or subdirectory, which is named after the file that we have converted. But now this is going to contain image files, which are going to have NII extensions in their name. Okay, so finally, to see what we've done, we're going to use the display menu. Okay, but now we're not going to use MEG. We're going to select images. We're going to navigate to our new subdirectory and select one of the conditions. Okay, so here I have selected the familiar.nii, which now is a one of those four-dimensional, that's to say, three-dimensional volume times trial data sets. And this is indeed the first trial or first volume of this, which is going to show up in our main display window. And this is what I've showed you before, but it will also have the crosshairs, the position of the crosshairs, and which voxel it is, and what the intensity of the signal is at that time. Okay, so thank you very much for your attention, and I hope you enjoy pre-processing data and the rest of the SPM course.